Hello students, so we are starting with the Neet series of PYQ. So today's chapter is the chemical kinetics. So let us begin. So the very first question we have here is the addition of a catalyst during a chemical reaction alters which of the following quantities. So when we have a reaction, let us take a reaction of the reactants, it is converted into the product P. So this is the product P and this is the reactant R. Now when the reactant is converted into the product, so this amount of energy, which is called as the activation energy. Now in presence of catalyst, it chooses another part. Okay, it chooses another part and the amount of energy required to convert the reactant into the product changes. So the catalyst mainly affects the activation energy. Now we can see here the path changes. Now in this path, the activation energy, this is the activation energy, this is also changing. Okay, so now we have here, so when we are writing the equation, the RNS equation, we have here as K is equals to A into e to the power minus EA upon RT, minus EA upon RT. So here we know that K is the rate constant, K is the rate constant, and here EA is the activation energy. Here EA is the activation energy. Now we know that whenever the activation energy changes, the rate constant also changes. So the question asked here is that during the addition of a catalyst during a chemical reaction alters the which of the following quantities. So the answer is 4, because when the activation energy changes, the rate of a reaction also changes, as we have the formula Fk is equals to R is equals to K into A to the power n. So we know that, so when the K changes, the rate constant changes, the rate of a reaction also changes. This is the rate of a reaction and this is the rate constant K. So it is the option number 4. Now the next question, this is in 2018 question. Okay, so we have the question here is when the initial concentration of reactant is double, the half-life period of a zero order reaction is what? So we know that the formula for the half-life, we know that it is for a zero order reaction, we'll write here for zero order reaction, we know that half-life T of half is equals to A naught upon 2 of K. So we know that T half here is depending directly on the concentration of initial concentration A naught. So as the reactant is double, so obviously T half will also be double. So the answer is option number 4. As the reactant is double, so the half-life is also double. Next question. Next question here is okay. So the next question here is for a first order reaction A converting into product, the initial concentration of A is 0.1 molar which becomes 0.01 molar after 5 minutes. The rate constant of a reaction is. So here it is mentioned that it is a first order reaction. So we know that for first order reaction, we know that it is the formula rate constant K is equals to 2.303 upon T into the log of A upon A minus X. Okay, A minus X. So here the initial concentration is 0.1 molar and the final concentration, which is A minus X, is 0.01 0.01 molar. Time t here given is 5 minutes, and as we know, if it's given you in minutes and the option you find in minute, let it be in minutes. You don't need to convert into second. So by putting the formula, let us solve the question here. Okay, we will solve in the next page. Okay, so we have to find the formula. Okay, so k is equals to 2.303 upon t into log of a upon a minus x. Okay, so now we'll put the value, which is 2.303 time is 5 minutes. Okay, then log of initial concentration is 0.1, and after time it becomes 0.001. Now let us solve the equation. 0.30315 into we'll take 0.1 as 10 to the power minus 1, and here we'll take this as 10 to the power minus 1, 2, 3, which is 10 to the power minus 3. So now we know that 10 to the power minus 1, when this goes upwards, 10 to the power plus 3. So log of this 2.303 upon 5, this is equal to 10 to the power 2. Okay, now we know that log of 10 to the power x will become x. Okay, so log of 10 to the power 2 is actually 2. So we'll write 2.303 upon 5 into log of 10 to the power 2, which is actually 2.303 upon 5 into 2, which is equal to 2.3 into 2 is 4.6, which is 4.6 divided by 5. So when we divide 4.6, so when we divide, so we'll get the answer. We'll take 46 divided by 5. We'll take 10 to the power minus 1 outside. Okay, so it is 5 9s are 45, 1, 0, it is 2. As it is minus 1, so it is 0.92. So what is the value of rate constant k is 0.92 minute inverse, which is the option 1. Now the next question. This question is, a first order reaction has a specific reaction rate of 10 to the power minus 2 second inverse. How much time will it take for 20 gram of the reactant to reduce to 5 gram? Okay, so this is also the same first order reaction. So we know, we did in the previous question, that for the first order reaction, which is for the first order reaction, see it's written here, the first order reaction, it is given initially it is 20 gram, then afterwards it became 5 gram. Now how much time? We have to find the time here. We have to find the time, and the rate is 10 to the power minus 2 second inverse. So let us put the formula and we'll solve the question. For first order reaction, it is k is equals to 2.303 upon time into log of a upon a minus x, or this is the formula for first order reaction, which we did in previous as well. Now let us put the formula, and we have to find the time t. We have to find the time t. So time t is equals to 2.303 upon k. What is the value of rate constant? K is 10 to the power minus 2 into log of, what is the initial? Initial is 20, and how when it is completed, it is like product is A minus X is 5 gram. Okay, so this is 5 gram. Now we have we'll divide it 20 and 5, so we know that it is 4. Now taking the log value, we know that log of 2, log of 3 and log of 4. This log of 4 can also be written as log of 2 to the power 2, which is 2 into log of 2. Else you can directly put the value as 0.301, 0.477, 0.602, and this is also, you'll get the same as 2 into 0.301 is actually 0.602. So let us put the values and substitute. We'll get the answer. This time t is equals to 2.303. Now we'll take 10 to the power minus 2 in the numerator. Okay, so this will change 10 to the power 2, and how much is log 4 value is 0.602. Now we'll multiply the answer. Now we'll multiply, we will just multiply 0.6 and we'll take 2.3. So when we're multiplying, okay, when we're multiplying, so we'll multiply 2.3 into 0.6. 2.3, 0.6, 6 3s are 18, 12, 6 2s are 12 and 13. 1.2 points, so that 1.38. So let us put the value here. It is 1.38 into 10 to the power 2. This comes down here. So what is the value here is almost, it is 138 second. So the time is 138 second. It is the option number 2. Now next question. Okay, this next question is, if the rate constant of a first order reaction, this is again a first order reaction, is K, the time required for the completion of 99% of the reaction. Here it is telling 99% of the reaction is completed, yani ke 100 minus 99 is 1. So how we will solve this question? As we know from the previous, as we did, that first order reaction is, the formula for the first order reaction is K is equals to 2.303 upon time, which is log of A upon A minus X. So here in this question we are asking the time. So we'll take the time here, and the rate constant is given as it is 2.303 into K. Now the initial, it is asking in percentage. When it is asking in percentage, this A value is your 100% and your A minus X is your 100 minus 99 is your 1%. Okay, this is your 1%. So we'll write log of 100 upon 1. And we know that log of 100 is, this log of 100 is actually 10 to the power 2. Correct, and we did 10 to the power 2. If you take log of 10 to the power 2 is actually 2. Okay, so we'll get the answer as 2.303 upon K into log of 10 to the power 2, which is again 2.303 upon K into 2. So when we multiply, it is 2.3 into 2, which is 6, 4.6. Okay, and if you take 0.3, so you'll get 0.6. So the answer is 4.606 upon K. This is the time. So here when we match, we get the option number 1 here. Okay, now the next question. Okay, so this is a little interesting question. Okay, so here we have a question as that for a chemical reaction N2 plus 3 hydrogen plus 2 ammonia, the correct option. Here for finding the correct option here, we know that rate of disappearance and rate of appearance. So when we are writing the rate expression, this is in the form of stoichiometric form. So we know that how we'll express it. Suppose for a general reaction, when we write, we have like, suppose let us take a reaction of A plus B, okay, converting into C. Okay, so here if we put the stoichiometric as this is M1, this is M2, this is N1, these are your reactant. Okay, these are your reactant and these are your products. So when we are writing the we're writing in the rate according to rate expression, the concentration with respect to time. Okay, so we are writing as d of A upon dt, okay, d of B upon dt, that is with respect to time, okay, then d of C with respect to time here. Okay, now we'll put the values of the stoichiometry. This M1 will put in the denominator. This will be your M1, then this will be your M2, this will be your N1. Sorry. Now as we know that with time the concentration of reactant decreases and the product and the concentration of product increases. That is, with time concentration of reactant decreases and the concentration of product increases. Okay, so here so here we'll put the value minus. Here minus doesn't mean it is negative, it just means with time the concentration of reactant is decreasing, and we'll write here positive, which means with time the concentration of product is increasing. Now let us compare with this equation with the nitrogen. So we'll write as N2 plus 3 hydrogen gives 2 NH3. Okay, so here we'll write d of N2 with respect to time, d of hydrogen with respect to time. Well, this 3 will come as 1 by 3. Okay, and then for nitrogen, ammonia DNH3 with respect to time, and this time we'll write as 1 by 2. As I said, for as a reactant are decreasing with respect to time, so we'll put minus, and this is positive. Let us compare these three equations which have been given. So when we take the first option, okay, when we take the first option, you can see here it is minus of N2, but the stoichiometric isn't given in the numerator, which is incorrect. It has to be in the denominator. When we take the second option, the reactant is negative, correct, but here the product is given in negative, which has to be positive, which is incorrect. It has to be plus 1 by 2. So this is plus 1 by 2, but is given minus. So this option is incorrect. This option is also incorrect. Now let us take the third option, minus n by 2, which is correct, and this is plus, which means nothing is given when it is plus, and this is correct. And if we take third option also, see this is 3H hydrogen, but here it is given numerator, this is also incorrect. So the option 3 is the correct option.